In this video, we're going to review section 2.4 and the second derivative, but this time we're going to be given a function that's represented by a chart. And the goal here is going to be to find out where the second derivative, f double prime, is positive or negative. In order to do that, we're going to have to know what the first derivative is. So remember, the first derivative is just the instant rate of change at a particular point. But because we're given a chart, we're not going to be able to compute that exactly. We're going to have to settle for estimating it or approximating it instead. The way we're going to approximate it is by average rates of change. So remember, first derivative is just the instant rate of change, but we're going to approximate that here by the average rate of change, which, as you recall, is just the difference in the y's divided by the difference in the x's. Okay. Now, remember, what kind of information did we get from the first derivative? If the first derivative was positive, that meant that the original function f was increasing. If the first derivative was negative, that meant that the original function f was decreasing. Let's apply that same reasoning now to the second derivative. If the second derivative is positive, that should imply that the first derivative is increasing. Why? Because the second derivative is just the derivative of f prime. And so all the stuff that we know about f prime, about the first derivative, will also hold for the second derivative, but applied to f prime. And so, again, if f double prime is positive, that should imply that f prime is increasing. And similarly, if f double prime is negative, that should imply that f prime is decreasing. So let's just write that down. So if f double prime is positive, this should imply that f prime is increasing. Whereas if f double prime is negative, that should imply that f prime is decreasing. And this is what we're going to be looking for, except in terms of average rates of change. If the average rate of change is increasing, we should expect the second derivative to be positive. If the average rates of change are decreasing, we should expect the second derivatives there to be negative. And that's why I've drawn these little boxes here, because that's where we're going to find the average rates of change over these intervals. For example, 0 to 2, 2 to 4, 4 to 6, etc. So let's get started. So in this first box, let's compute the average rate of change over the interval 0 to 2. That's going to give us 14 minus 12 over 2 minus 0. So that's just 2 over 2, which is 1. Let's go to the next interval. Difference in x's is 4 minus 2, that's 2. But difference in y's is 17 minus 14, which is 3. And that's just 1.5. Go to the next interval. 21 minus 17 is 4. Difference in x's is again 2. So we get 2 here. We go to the next interval now from 6 to 8. We get that the difference in the y's is 19 minus 21, which is negative 2. Divided by 2, which is negative 1. Okay, so we go to the next one. We get 15 minus 19, which is, of course, negative 4. Divided by 2, which is negative 2. And then finally from 10 to 12, which is 23 minus 15, so we become negative, so it becomes positive again. Divided by 2, and we get 4. So let's take a look at what happened here. We go from 1 to 1.5 to 2, so it's all increasing. And then it drops down to negative 1, so decreases, drops down to negative 2, continues to decrease, but then goes up to 4, so then increases. So let's just draw that in another way. So let's say here that from 0 to 6, we can see that the average rates of change, average rates of change are increasing. Then it begins to decrease from 6 to 10, but then it increases from 10 to 12. So again, I'm referring here to the average rates of change, so I'm talking about the first derivative. Now let's just draw this number line here. On the right end we're going to put 12, on the left end we could put 0. In between we'll put 6 and 10. From 0 to 6, f prime is increasing, so that means we expect f double prime to be positive there. F prime decreases from 6 to 10, and so we expect f double prime to be negative there. But then from 10 to 12, it becomes positive again because f prime is increasing. And this is how you can tell whether or not the second derivative is positive or negative from the chart. You just look at average rates of change and determine where they're increasing and decreasing. Remember, these average rates of change will get closer and closer to the actual derivative as long as these x values are small. Here we have differences of 2, so they might not be so accurate, but the point is this is an estimate. This will give us an idea of where the second derivative is positive or negative.